Hello everyone, so in this function of x and y, we are going to calculate the candidates for the extreme points. So what are the extreme points? These are when f partial x and f partial y are all 0. So what is f partial x? It is just y minus 2 times x times y minus y squared. And we want f partial x to be 0, so this one is going to evaluate to 0. And we also want f partial y to be evaluated to 0, so x minus x squared minus 2 times x times y will be equivalent to 0. So sort these two equations, we get y times 1 minus 2x minus y to be equivalent to 0, and also x times 1 minus x minus 2y to be equivalent to 0. So we can see that the first solution to this set of equations would be x and y are all 0. And the second solution to this set of equations would be, well, 1 minus x minus 2y is 0, and 1 minus 2x minus y is also 0. So solving these two equations, we get x and y are all 1 over 3. Now, the third solution would be when x is equivalent to 0, but y is not. So x is equivalent to 0, and, well, since y is not 0, 1 minus 2x minus y would definitely be 0. So we can see that y is equivalent to 1. And the last solution to this set of equations will be when y is equivalent to 0. When y is equivalent to 0, x is definitely 1. So there we have 4 candidates. The first candidate is 0 and 0. The second candidate is 1 over 3 and 1 over 3. The third candidate is 1 and 0. And the last candidate is 0 and 1. So these are the candidates of extreme points of this function, f of x and y. Now, in the second subproblem, we're going to differentiate whether these are actually the extreme points or they're just the saddle points. So to do that, we need to use this determinant. This is f double partial x times f double partial y minus the square of f partial x partial y. So if the value of this determinant is smaller than 0, then it is a saddle point. Now, when the determinant of this equation is actually larger than 0, we need to see if f double partial x is larger than 0. If f double partial x is larger than 0, that means that it is concaving upwards, so it is actually the minimum value. Now, when f double partial x is smaller than 0, then that means that it is concaving downwards, and so it is actually the maximum value. So what is the determinant? It is negative 2y times negative 2x minus the square of 1 minus 2x minus 2y. Now, we substitute x and y with all these equations. With x and y equivalent to 0 and 0, the determinant is negative 1. And then when x and y equals to 1 and 0, it is also negative 1. And then when x and y equals to 0 and 1, it is also negative 1. So for these 3 points, these are all saddle points. Now, if x and y equals to 1/3 and 1/3, we see that the determinant equals to 4 over 9 minus 1 over 9. So it is 1 over 3, well, 1/3. And we see that 1/3 is actually larger than 0. And we see that f double partial x is negative 2 over 3, and it is smaller than 0. So based on our previous reasoning, we see that it is actually a maximum value. So between all these 4 points, there is only one maximum value, and that is when x and y equals to 1/3 and 1/3.